Good morning, students. We have already completed the production of citric acid, and so we will move on to the production of your acetic acid. So you know that acetic acid is also known as your ethanoic acid. It is known as your ethanoic acid, and it is known as ethanoic acid. It's an organic compound which gives your vinegar. You know that we are very used to vinegar. We have apple cider vinegar and various types of vinegar. So it gives vinegar a sour and pungent taste. Okay. Now it is important chemical agent and industrial chemical. It is an industrial chemical and is used in the production of polyethylene terephthalate, mainly used in soft drinks bottle. So polyethylene terephthalate is mainly used in soft drinks bottle. Cellulose acetate, mainly for photographic film. Polyvinyl acetate for wood glue, as well as synthetic fibers and fabrics. So in households also, dilute acetic acid is often used as a descaling agent. So in the food industry, acetic acid is used under the food additive as an acidity regulator. So acetic acid has a huge role to play in the industry. Next comes its structure and property. So you know that its structural formula is the simplest carboxylic acid, which is your acetic acid. It is pure. Water-free acetic acid is called as glacial acetic acid. Is a colorless liquid which basically freezes below 16.7 degrees C to colorless crystalline solid. It is a weak acid because at the standard condition for temperature and pressure, this dissociated acid exists in equilibrium with the undissociated form in aqueous solution, and in contrast to strong acids which are fully dissociated. So you understand this dissociation. In weak acid, because of the standard condition of temperature and pressure, this dissociated acid exists in equilibrium with undissociated acid. Okay. Other name of your acetic acid is your ethanoic acid, as we have already with the systematic name, and acetyl hydroxide. Okay, hydrogen acetate, ethylic acid, methane carboxylic acid are the various other names. Next we will move on to the history of acetic acid. The use of acetic acid dates back to the 3rd century BC, when the Greek philosopher Theophrastus described how vinegar acted on metals to produce pigment. And that is being useful in art, including white lead, lead carbonate, verdigris, a green mixture of copper salt, including copper to acetate. Then, in 8th century, Muslim alchemist Jabir ibn Hayyan was first to concentrate acetic acid from vinegar through distillation. In 1847, the German chemist Hermann Kolb synthesized acetic acid from inorganic material for the first time, and this reaction sequence consists of chlorination of carbon disulfide to carbon tetrachloride, followed by pyrolysis to tetrachloroethylene and aqueous chlorination to trichloroacetic acid, and concluded with electrolytic reduction of acetic acid. By 1910, most glacial acetic acid was obtained from pyroligneous liquor from distillation of wood. So now we will move on to the industrial production of your acetic acid. Acetic acid is produced both synthetically both synthetically and by bacterial fermentation. So you know that this is being produced both synthetically and by bacterial fermentation. So the biological, today the biological route accounts for only 10% of the world's production. But it remains important for vinegar production, as the world's food purity law stipulates that vinegar used is must from the biological origin. So nowadays vinegars are basically prepared from the biological origin. Now, you know that acetic acid is produced and excreted by notably Acidobacter genus, Clostridium acetobutylicum, and these bacteria are universally in foodstuff, water and soil. So they are basically found in foodstuffs, water and soil. Vinegar may be classified on the basis of the material which is being used, like fruit such as apple and grapes produce cider vinegar. From malted cereal, barley, malt vinegar. From ethanol, spirit vinegar, and must contain at least 4 grams of acetic acid per 100 ml of sample. Now, manufacture of vinegar involves 2 steps. Fermentation of sugar to ethanol. So first you start with carbohydrate and that is basically being converted to ethanol, and then oxidation of ethanol to acetic acid. So that is very important. So the first step is aerobic process carried by Saccharomyces cerevisiae. So it is the Saccharomyces cerevisiae which is being basically used for the conversion of your fermentation from sugar to ethanol, and then it is the Acetobacter, Gluconobacter, Acetobacter and your Gluconobacter which basically further converts and oxidize alcohol to acetic acid. Now, if we move on, we know that the raw material for the vinegar, the raw material for the vinegar as you get to see is your vinegar is produced using fruit juice, starchy vegetable, etc. The vinegar production mainly involves 2 processes. One is your slow or let home process, that is one. Another is quick or French or Ken's process. So we basically prepare vinegar in 2 different processes. Now, if we move on to the slow process, in this process predominantly apple juice is used for alcoholic production by batch process. So here we use apple juice. We use apple juice for its production, and fermenter is primarily filled with fermented juice and allowed to undergo process of acidification. So it undergoes process of acidification. Now if we move on, which is supplemented with vinegar bacteria, mother liquor vinegar, a film of vinegar bacteria called mother of vinegar, we call it mother of vinegar, is basically being used. So I will move on to my next portion. So if you if we see that it undergoes process of acidification, which is supplemented with the vinegar bacteria, and it undergoes a batch previous batch of vinegar. Means from the previous batch of vinegar you take the bacteria, and it is called as mother of vinegar. We call it mother of vinegar. We call it mother of vinegar. A film of vinegar bacteria called mother of vinegar should go on the surface of the liquid, which indicates that ethanol is oxidized into acetic acid and form your vinegar. Now when I am talking of quick process, so if we focus it, quick process, in this process about 1/9 of the barrel is filled with raw vinegar from previous run, and the acidification by the vinegar bacteria can be checked by growth of competing microbes. So the barrel is then filled by alcoholic hydrolysate up to half level. So first what you are doing, 1/9 of the barrel is filled with raw vinegar. Then from previous run, then the acidification of vinegar bacteria can check the growth of competing microbes. The barrel is then filled by alcoholic hydrolysate up to half level. So half level alcoholic hydrolysate is there, right? And up to half level, and the bacteria will grow as a film on the top of the surface and will take place, the fermentation take place at 21 to 30 degrees C. The acetic acid is withdrawn and is replaced by equal quantity of alcoholic liquid. This is continuous fermentation. You remove the acid, you add the alcohol. Again oxidation takes place, alcohol becomes acid. So the floating frame is provided to support the vinegar bacteria to prevent from dropping, which may result in retardation and acidification. Next is the generator process. The oxidation of the alcohol is carried out in a cylinder tank in wood called generator. The interior of the tank is divided into three parts: upper section, middle section containing a slimy growth of acidic bacteria supported on a birchwood, okay, and a bottom section. The alcoholic liquid from the first step of each fermentation is fed into the upper section and is allowed to trickle down into the lower section where acetic acid bacteria is there. Air enters the middle section and is vented on the top, and the oxidation process is exothermic and hence controlled by the temperature of 30 degrees centigrade, and the product is basically collected at the bottom. So basically this whole fermenter is divided into the top section, middle section, bottom section. So the top section is associated with the addition of alcohol, the middle section the fermentation, and the lower section is the product. Next comes aging and finishing of vinegar. The final product has to undergo the following step: aging to improve the body and taste, finally pasteurized to 60 to 66 degrees for few seconds before marketing. Uses: solvent. Glacial acetic acid is an excellent polar solvent used as a solvent for recrystallization to purify organic compounds. As a vinegar, in the vinegar acetic acid is only 4% and are used directly as condiment and also in pickling of vegetables and other fruit. And ester application production, dilute solution of acetic acid are also used for their mild acidity. Example include the use in bathing soap during the development of photographic film, and as a descaling agent to remove lime scale from taps and kettles. So that's all about the vinegar and acetic acid production. So please, if you have any comments, we will be discussing in our live class, and otherwise you can also comment on Google Classroom. Whatever assistance you need, I will be providing it to you. Thank you.